5, Lesson 5, and if your swords are ready, let's get started. Today we're going to look at how to read a database, how to create a double bar graph, and identifying quadrilaterals. And we're going to do the first two together. So let's talk about reading databases and creating double bar graphs. So a database is an organized set of a large amount of information that's quite often made on a computer. So here we have a database. Sean looked up databases comparing hockey players in 1984 and 2006. So let's just look at this and see some of the information that you get in a database. You can see there's a lot. So over here we have the Oilers from 1984 to 1985, when I was 5 and 6 years old, if you are curious. And you have Wayne Gretzky, so the player's name. You have their birthplace, his was Ontario. You have their age, he was 23 at the time, and the number of points he'd scored, which was 208. And you can find that information for all the players from the Edmonton Oilers in 1984 to 1985. Same thing happens over here, except it's for 2006 to 2007. So for example, some of the questions you could answer were there more players from Canada in 1984? You could say, who was the highest scorer in 2006? You could answer, who was the youngest player in 1984? Lots of questions can be answered from a database. There's lots of good information on there. But then along comes Sean's dad, and he says that when he was young, most hockey players were born in Canada. He doesn't like how many hockey players now come from other countries. So Sean decided he's going to use the databases to create a graph and see if his dad is right. So the first thing Sean's going to do is use a tally chart to see which players were born in and outside of Canada in each year. So here's a tally chart, or it's not a tally chart yet, but we'll go through. So in 1984 to 1985, I have Wayne Gretzky born in Ontario, then I have Finland, then I have Ontario, Quebec, BC, Alberta, Ontario, 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 Sweden, Quebec, Alberta, Ontario, Alberta, USA. Then I look at 2006, 2007, and I've got Quebec, check, check, BC, Saskatchewan, Ontario, Alberta, Alberta, Quebec, USA, Ontario, Norway, USA, Sweden, not a very good thing, but that's all right, USA, Sweden, Quebec. So there's my tally chart. Now I'm going to graph that, and remember we've talked about how to make a double bar graph. I'm going to pick one color for each group, so I'm going to use blue to represent 1984 and yellow to represent 2006, and I'll put them both on a graph. And here's how the graph ends up looking. So you can see from this graph we have a title, we have players born in Canada and players born outside Canada. We should have a label here, we're missing something, so there, now I have my number of players labeled. And blue is from 1984 to 85, and yellow is from 2006 to 2007. So you can see that Sean's dad actually was right. There were more players from Canada in 1984, and there were more players outside Canada in 2006, but it wasn't actually that big of a gap. So there you are. That's how you use a database and make a double bar graph. And now we're going to move on and do a study jam together about identifying quadrilaterals.
Zoe is playing with a new band, and they decided to call themselves the Quads. Sam tried to convince her to use different quadrilaterals for the cover of their first CD. Not sure if that's a cool idea, but let's see. Let's show Zoe each of the different types of quadrilaterals she can choose from. We'll start with the rectangle. A rectangle has opposite sides that are congruent, or equal. It also has 4 right angles. Each pair of opposite sides are equal. And see how teacher once told me that a trapezoid looks like the bottom half of a triangle. It's true though, don't you think? So here's what we got. A rectangle has two pairs of congruent sides and four right angles. A square has four congruent sides and four right angles. A parallelogram has two pairs of congruent sides that are also parallel. A rhombus looks like a diamond, with four congruent sides, and the opposite sides are parallel. A trapezoid has only one pair of parallel sides. That just about covers it. Here's the confusing thing. Quadrilaterals can be classified in more than one category, like a square is a parallelogram, and a rectangle, and a rhombus. If you have a quadrilateral that you need to classify, ask yourself, does it have four sides? If it has more or less, it is not a quadrilateral. Does it have right angles? If all four are right angles, it's a rectangle or a square. Does it have equal or congruent sides? If all sides are equal, it's a square or a rhombus. If some of the sides are equal, it could be a rectangle or a parallelogram.
And that's it for today. For the review, I just would like you to copy down these notes and do a quick sketch of each of the four types or five types of quadrilaterals. And tomorrow you can just show me that you did the notes, and that's all you have to do. So I will see you tomorrow.